What if the very machines we're building to guard our privacy are also becoming the most powerful forms of intelligence on Earth? And what if the computers of tomorrow don't even use electricity at all, but instead think with beams of light? It sounds like a paradox, maybe even science fiction. But right now, it's becoming reality. In just the past few weeks, Google, Johns Hopkins University, a small California startup, and Microsoft have each dropped bombshell breakthroughs that redefine what technology can do. We're not talking about incremental upgrades here. These are leaps forward so dramatic that, once again, the ground beneath us is shifting. A billion-parameter private AI. A multilingual model trained on nearly every language known to humankind. Speech recognition that finally feels frictionless. And a computer that calculates using photons instead of electrons. The crazy part? All of this is happening at the same time. The future isn't waiting patiently on the horizon, it's crashing down right now. And if you're not paying attention, you risk waking up in a world where the rules of technology, privacy, and communication have already been rewritten without you realizing it. So let's break this down, one step at a time. Today we're diving into 4 seismic advances that could completely reshape the way humans interact with machines. Google's VaultGemma, the most powerful private AI in existence. Johns Hopkins MMBERT, a model fluent in nearly every human language. ER3, a speech recognition breakthrough that obliterates rivals. And Microsoft's optical computer, a prototype that ditches electricity for the speed of light itself. Stay with me until the end, because these aren't just isolated stories, they connect into a bigger picture of where the entire AI revolution is heading. And trust me, once you see how the puzzle pieces fit together, the urgency to adapt will hit you like a freight train. Section 1, Google's VaultGemma. Google has just unveiled something that sounds almost impossible, a billion-parameter AI model that's both open and private. It's called VaultGemma, and it's the first of its kind, a system designed to be powerful without ever risking the leakage of private information. Here's the problem they tackled: most large AI models are trained on huge swaths of internet data, which means they sometimes memorize details they shouldn't. With clever prompts, people have shown that you can sometimes coax out private data, emails, phone numbers, even entire passages word for word. That's a terrifying risk in a world where trust in AI is already shaky. VaultGemma flips the script. Instead of just hoping sensitive data doesn't slip through, it uses a technique called differential privacy. Think of it this way: every time the AI learns something, it sprinkles in a dose of randomness. That randomness blurs the fine details but preserves the bigger picture. So the model can understand what a phone number looks like, but it will never repeat the actual number it saw during training. The architecture is still transformer-based, like most modern AIs, but optimized for this privacy-first design. With 26 layers and the ability to process about 1,000 words of context at a time, it's leaner than the biggest models out there, but that's intentional. Privacy requires constraints, and Google engineered shortcuts to make it practical. Training it was a monumental job: 13 trillion tokens of filtered data, carefully scrubbed to exclude unsafe or personal information. Over 2,000 cutting-edge Google AI chips worked in parallel, processing more than 500,000 words per step, repeating this cycle more than 100,000 times. The result? A model that, in tests, leaked zero private data, while other non-private systems failed. And while it may not yet match the absolute sharpest non-private models in raw performance, it sets a precedent. VaultGemma proves you can build something massive, fast, and useful without sacrificing user trust. Pattern interrupt: imagine that, the biggest AI breakthrough of the year isn't about making machines smarter. It's about making them forget. Section 2, Johns Hopkins MMBERT. For years, the world of multilingual AI has been stagnant. One model, XLM Roberta, has held the crown, but it was built with a heavy bias toward English. For most of the world's 7,000+ languages, AI progress has felt like scraps from the table. That ends now. Johns Hopkins just launched MMBERT, and it changes everything. This system was trained on 3 trillion tokens across 1,833 languages, basically, the largest linguistic buffet AI has ever consumed. Instead of letting English dominate the mix, MMBERT gave equal weight to smaller, rarer languages, gradually folding them in until the model could grasp the full global spectrum. The architecture is sharp and efficient: 22 layers, hundreds of millions of parameters, and, this is big, a context window that can handle over 8,000 words in a single pass. For perspective, its predecessor could barely handle 1,000. That's like upgrading from a bicycle to a bullet train. And the results? Jaw-dropping. In English, MMBERT keeps pace with the best modern systems. But in global benchmarks, especially in underrepresented languages like Farsi and Tigrinya, it crushes the competition, including OpenAI's O3 and Google's Gemini Pro. Even more impressive, it runs up to 4 times faster, making it practical for real-world use. Think about what this means. Millions of people who've never had accurate AI tools in their native language suddenly gain access. Search engines, translations, educational apps, all of them become more inclusive, bridging the gap between the tech elite and the rest of the planet. If you thought machines finally speaking your language was wild, wait until you hear what's happening in voice AI, because that's where things are about to get personal. Section 3, Twin Minds Ear 3. Voice is the most natural way humans communicate. Yet, until now, speech recognition has always been frustrating. Errors pile up, costs soar, and switching between languages often breaks the system. But a California startup called TwinMind may have just solved it. Their new model, Ear 3, is claiming the crown as the most accurate and affordable speech recognition system ever built. The stats back it up, a word error rate of 5.26%, compared to 8% plus from competitors. That may look small on paper, but in a 2-hour transcript, it means thousands fewer mistakes. It also outperforms rivals in speaker separation, the ability to tell who's talking when. Ear 3 scores 3.88%, beating the previous record holder, Speechmatics, at 3.9%. Add support for more than 140 languages, and you have a tool that doesn't just transcribe, it understands. Even the price is disruptive, just 23 cents per hour of transcription. That's game-changing for industries like medicine, law, and business, where accuracy matters but cost usually holds back adoption. How does it work? Ear 3 combines several open-source models and fine-tunes them on carefully labeled audio from podcasts, films, and human-annotated speech. A sophisticated pipeline cleans the sound, separate speakers, and even handles code switching, when someone blends 2 languages in the same sentence. Most systems stumble here. Ear 3 sails through. There are limits. The model is too large to run fully offline, so it relies on the cloud. But the company has designed fallback systems and encrypted transcript storage to address privacy concerns. The impact? Doctors dictating notes without constant corrections. Lawyers saving hours on clean legal transcripts. Businesses transcribing meetings accurately at scale without massive costs. Imagine Siri, Alexa, or Google Assistant suddenly becoming smarter than your actual assistant. Would you still yell at them for mishearing you? But as wild as Ear 3 is, it still runs on silicon chips. Microsoft, however, is building a machine that ditches electricity altogether, and that's where things get truly mind-bending. Section 4, Microsoft's optical computer. Most of us think computers will always run on electricity. Billions of tiny transistors flipping on and off, powering everything from your phone to the most advanced AI models. But Microsoft is experimenting with a prototype that breaks that assumption completely. Meet the analog optical computer, a system that calculates using beams of light instead of electrons. Yes, light. Every flash, every pulse of brightness encodes part of the math. Instead of current zipping through circuits, photons bounce through micro-LEDs and sensors, performing calculations at the speed of light. Why does this matter? Energy efficiency. Traditional chips waste enormous amounts of energy flipping transistors billions of times per second. An optical system avoids that bottleneck, which Microsoft claims could make it up to 100 times more efficient for certain tasks. They've already tested it. In image recognition, it performed on par with digital chips. In medical imaging, it reconstructed brain scans using only 62% of the original data, without losing accuracy. That could mean shorter, less stressful MRI sessions for patients. In financial optimization problems, the optical computer even rivaled some quantum systems. Right now, it's just a prototype. But scaled up with more micro-LEDs, it could one day handle millions, or even billions, of variables at once. Imagine AI models trained not over weeks but in hours, on machines that barely consume energy. Here's the unsettling question. Would you trust a computer that thinks with light instead of electricity? After all, it feels alien, like we're inching toward the kind of machines we only imagined in science fiction. Maybe the real question is, What happens when our laptops double as flashlights? Okay, not really, but admit it, you pictured it. Together, these breakthroughs, VaultGemma, MMBERT, EAR-3, and optical computing, aren't random events. They're pieces of a puzzle pointing toward a future where AI is smarter, faster, more private, and maybe even powered by the speed of light. The question is, are you ready to adapt before it's too late?